Draft physics video. Yay. It's been a while. Busy with things and whatever, and it's just always something. And so I have, stuff I had to do, blah, blah, and then partition on my hard drive disappeared. And I haven't had that happen before, just the partition disappears. And what a hassle. Just, all the freeware used to be free, and now it's like it's kind of like let me insult your intelligence ware or something. I don't know what you want to call it, because it'll scan, it'll find the partition, it'll show you there's files, and then it'll say pay us $30 or tough shit. We're not going to do anything. It's like, well, why did you bother showing me nothing? It's just it's evil. I mean, especially when a scan takes a couple of hours, and even that mini something or other. The thing that used to be Western Digital, and then they made it, I don't know, I thought it was open source, but anyway, apparently not, because all of their partition software is, they say it's free and for non-commercial use and all that. No, it doesn't do anything, though. I mean, it's useless in that it won't solve any problem. But anyway, so I finally found a open source test disk, yeah. Anyway, and it's just a Windows executable in the sense that it runs in a DOS window, and so it's not like user friendly tremendously, but it did work. So, but all day, it's just a waste of an entire day, just because the scans took forever, and it just, whatever. So anyway. And then it corrupted, because I had fucked around so many different programs, like 5 different ones were fucking around with my hard drives. It screwed up the boot sector, so now the thing wouldn't boot, on the other computer. So I had to fix that. And, anyway. Computers. I was tired anyway. My eyes, allergies, I guess. So, anyway. So I've just been kind of cut down in my performance a little bit, which is irritating. But anyway, so I've been thinking a lot about the physics stuff, though, so it's not like it's out of mind. And so the conversation is sort of interesting in the sense that I think you can construct these alternative theories, wave theory versus particle theory, if you want to say it that way. Forces defined as, are ambiguously described as undefined fields. So, I mean, we have the bent space field for gravity, the electromagnetic fields, the 2 of them for electricity, and, this kind of, just an idea of a field thing that is the force carrier, or the force conveyor, the thing that converts energy into energy, movement one place into movement another place, that kind of thing. And this alternative theory that basically says, no, it's not fields, they're real things, and the real things are invisible, but they move between one thing and another thing, like photons, and they make things happen. And but unlike photons, we can see them. We can't see magnetism. We can't see magnetons or gravitons or electrons, maybe. Which are really magnetons, so let's quit fucking around. The bits moving between the electron and the proton. So there's these 2 contrasting ways of looking at it. My opinion, it's hard to come up with evidence that decisively wins or loses for either theory. I'm saying that no one's presented me any decisive evidence that says it can't be as I'm describing it. These particles are doing it. It's perfectly viable. There's no facts. There's no evidence proving, demonstrating it can't be possible that. So if I say light won't go forward when you're moving half the speed of light, we don't have an experiment to prove it. I say the light's not going to go through the hole, blah, blah, blah. They say it will. We can't disprove each other because there's not experiments enough to demonstrate it. and the only experiments that exist that might be relevant require a huge number of assumptions built into the performance of the experiment. And so even when you get to something as simple as the two-slit experiment, the aperture experiments, they get very complicated very fast as soon as you introduce things like lenses and other manipulations of the form of the light going in, whether you put it through an aperture, you don't put it through an aperture. And I've sort of detailed some of that with the basic two-slit experiment, but it's also true with the more complex diffraction experiments, even the MIT videos on lasers, where I could show you that the beam splitter isn't what you think it is, and that is, it doesn't take half the light goes this way and half the light goes that way, and the two bits of light aren't at all affected. They're just half go this way and half go that way, and nothing's changed. Substantial change in the sense that the light that goes through it's going through apertures. It's essentially going through a diffraction gradient, and it's being spread. And so you can see this in the old MIT videos where the beam from the laser for one pathway is this size, and the beam for the laser for the other pathway is that size. So right away there's these things you can identify as problems in the assumptions of the experiment that may or may not be real hard evidence of you can't do that. Your results don't mean anything because you're not really measuring interference. You're measuring combining two different Newton's rings, essentially. One at this size and one at this size. Anyway, and so you have, these defects are important. These influences in experiments are important. There's lots of, you have to be careful where you make assumptions when you're analyzing something that's going through all these, I'm trying to think of the word for the, oh, sorry, a long day. Shit, I can't think of the word, the obstacle course. That's really an experiment involves a kind of obstacle course that the thing you're experimenting is going through, and there's all kinds of changes that might take place that you're not accounting for because of the different, you're almost putting different clothes on the players, and things are radically changing when you're going from one through each bit of the experiment. You're changing things. You're filtering is the word I would use. So anyway, so back to the basic point, which is what I'm seeking, and I think what others are also seeking, is evidence that is more decisive. So we could actually have hard evidence that demonstrated something like light being bent by force, that is by gravity or magnetism, or by even the nuclear forces, some evidence that light can be bent by an electron or a proton. Not that it has to interact with one, but that it can actually just go by one. This kind of evidence. And certainly the lensing evidence is, in my opinion, weak. And that's basically all there is for this bending of light, is some form of passing light through what arguably is atmosphere. And part of the irony is I was watching some 60 symbols videos on mass and density, and there was some new chick who was doing black holes and all that kind of stuff, and they were talking about these exoplanets, these whatever Earth-like whatever nonsense they talk about, and how they detect it, and and they're talking about the light from the source going through the atmosphere of the planet, and then we are able to detect it, light years away, which I'm a little skeptical of the idea that we can isolate such a small percentage of a sample of a sun's profile from light years away and to detect what would be theoretically a very tiny influence in the spectrum being caused by the planet. I mean, I haven't seen... See, these are the kind of things where you need to know more details about what assumptions go into these experiments, about what kind of how many photons they can actually collect, and what likelihood those photons are going to be, that you have any hope of finding that needle in the haystack of the light produced by that source. Whether it's even theoretically possible that such a tiny, an atmosphere only a few miles thick would be able to influence enough photons for us to be able to detect it at such a distance. But anyway, just the idea of it though. So here's the lensing argument all over again, in the sense that the problem with lensing images is what's light being affected by the atmosphere around suns, and what is light being affected by gravity. How do you make those distinctions, and where's the line of that distinction, where you've isolated your beam of light from the radiation field the sun's producing? That isn't gravity, but that is actual force, energy, and particle substance that's leaving the sun. Particles leave the sun. Electrons, lots of them, are ejected. Nucleuses are ejected. Pieces of matter fly off of the sun. So, and that gets to this density argument, which gets to the whole argument of what is matter anyway. Because they talk about neutron stars being regular stars where the matter is compressed, and that means the electrons and the protons combine to form neutrons, and so the sun is made out of all neutrons. And it all sounds okay, but we can't do that. That doesn't, in that sense, it doesn't sound okay, and we have no evidence that neutrons are particularly in love with each other. But they might be, because I think they're a dipole, like a magnet. So I think they like each other as long as they're arranged the right way. Arrange them the wrong way, and they're not going to like each other. So in that sense, it's consistent with my particle explanation that certainly neutrons would be what you get when you combine electrons and protons, which is a dipole, not a monopole. The monopoles are the electron and the proton. They're the filter, by my theory, for the two types of quanta that define force. All the forces are made of the polarized quanta. And all you have is the mass bits are they're just the communicators of the force. If there's more force coming at you than behind you, then you go that way. If there's more force behind you than in front of you, you go that way. And the matter just is obedient. The matter bits, the protons and the electrons. See, and that's the trick though. We're stuck with just as in biology, where you're stuck with this definition, this word called life. And life means not only the sperm cell, but the human that ejects it. Both of those things are called a living thing, and they're not really both living things by any real stretch of the imagination. Any common properties and attributes, they don't share many in common. We're a city and made of buildings. We don't call buildings cities, and city isn't building. It's really stupid to call them the same thing. Or brick and building. You can just do the metaphors in all kinds of ways about how undescriptive that is. And the problem is with matter, the word, is that the fundament of matter, the elemental bits of matter, which are the electrons, the protons, and the neutrons. And so you could say just electrons and protons if we concede neutrons are maybe just the combination of electrons and protons. So that's all you have as the matter bits, the substance of what makes something material. But the matter bits don't act like matter. The matter bits aren't matter. They're matter bits. That is, the electron and the proton can be given temporary velocity and acceleration, but they can't hold it. They can't collect a force like matter can. So an atom can collect force. An arrangement between an electrons and protons can collect force in a direction, a prejudice in a direction. But the single elemental bits can't. So matter can absorb velocity, can absorb the force, and as long as it's absorbed it holds it, like a battery. It stores the force. So this sort of relates to a Hofladay video where he was talking in general terms about energy. And energy really isn't. Energy is just the passing of this imbalance. I've used the term before, that it's just really where you see an imbalance is what we call something energetic. But the energy is just in the prejudice of more force on one side than another side. And if you neutralized all of those effects, that is, you froze something, there's no inherent energy, in a sense. In a sense that energy is just when you have a bias, more light shining from one side than another. Then it's revealed as motion, and that's what we call an expression or a possession of energy, as a possession of an element of this imbalance. And that's what a rocket ship has, is it possesses an imbalance in the sense that it is collected force in a direction, and it has a bias. It has more force going one way than it has the other way, and as long as it can hold that extra force, keeps it cycling inside of itself, it can hold that prejudice. That is, it can move more of its matter bits with the force going one way than the circle would require. So you'd say the circle is required. You have to feed it back. And the trick is, when you're going one way, you hit more bits of matter bits, more electrons and protons when the force goes one way, and less electrons and protons when the force goes the other way. And that way you neutralize you can have the circle, and you maximize the matter's movement in the biased direction, and minimize the effect in the opposite direction. And that's kind of what I'm arguing is the nature of inertia and velocity. That's what it's made out of. Things possess it and hold it because they've made it circular, but they've taken the advantage of having the wheel touch the road only on one side. The wheel turns, and it turns in both directions, so to speak. And the trick is, when it's turning in one direction on the road, and it's turning in the other direction in the air, and which one creates more friction and more opportunity for movement? Well, obvious. And the same kind of thing is happening inside of matter, would be my argument. All right, so these are all interesting conversations, but so again, we're back to the argument that we have to seek. I'm seeking in terms of playing with the two-slit experiment. So I have continued doing some experiments. I don't have anything. I could show you the junk I've gotten so far, but it's kind of junk in the sense that I've gotten great single-slit patterns out of the double slit. I used a wire that was like 1/10 of a millimeter thick, and the slit width I varied from about that same size, 1/10 of a millimeter, down to maybe 1/100th of a millimeter, thickness of a really thin piece of paper. I haven't gotten the broken pattern, and part of why I think I'm not getting it is because of the source. The source light has to be a particular kind of source light. I think if you put it through an aperture, I'll probably get the pattern, and without an aperture, I don't get the pattern. Something like that, I think, is causing the change in the pattern, because I'm not getting anything that's traditionally double slit. I'm getting hundreds of bars, but it doesn't diminish and then brighten and then diminish and brighten. It's not in any single slit envelope. So interesting. There's lots to it. It gets interesting the further you start moving the target, and you see that the little slits actually become slits. I mean, the bars become bars. So in one experiment I did get, was a little fuzzy, but it seemed to me to be something definitely worth pursuing. But at, say, 1 meter, you got just a bunch of bars, and then if you put it 10 meters, the bars themselves had little bars inside of them. So indicating, something's going on there. Well, anyway, so there's lots of room for playing with that. But yeah, so far, it's kind of funny that I'm not getting anything that I expected. And even to the point where in the bars were a little bit slanted. And the interesting thing was, if I stuck my finger in, even though I stuck it straight vertically, it would go in crooked. So I'm sticking my finger between the target and the slits, and somehow it's being distorted in terms of the shadow, which I thought, again, I'm just saying, so lots of little interesting things that I don't really want to do a video on until I have some idea, something to say about it besides, isn't that fucked up? And I want to eliminate my own fuck-ups from, part of the description, because I'm thinking the wire I used was copper, it's very reflective. It's kind of dangerous to use reflective things, so I do want to make them more opaque and less capable of creating some other reason for some pattern. So anyway, that's where I am on the experiment thing. Just working on stuff. I mean, it's just something like even little things. I just noticed with this laser, I can take, see it has a focusing lens that you can change, but the real key is you can take the whole thing off and get to just the laser. And you find out it's not as much of a laser as you think it is, in the sense that the light does spread quite dramatically from the original source. That it's kind of being forced to be a laser. It's not a laser like in a natural sense. It's the solid state emitter is not really emitting parallel beams of light, coherent beams of light, or culminated beams of light, and it's being forced by using a lens. And so again, this is, in my opinion, all those augmentations are just dangerous to being able to understand what the effect is. Is the effect the source light, or is the effect the actual experiment? And those are important distinctions to be able to be clear about before you can draw conclusions. Alright, so there were a few different things that I just thought were worth mentioning. So something I thought about was galaxies. And because we're talking about black holes at the center of galaxies and talking about different aspects of this motion thing. So it's the idea of the ice skater spinning, and then they bring their arms in and they spin faster. And a way of thinking about that, to make it illustratable to me, was I was just thinking about the average amount of the matter and how fast it's going. So you could say that if you took all the bits of if you just said there was a million little bits that are the spin of the person, some of the bits on the outside are moving much faster than the bits on the inside, just because they travel more distance in the same amount of time. And so there's an average speed for the average density. So you could say the outside bits, there's fewer, your arms are less than your body. And so when you bring your arms in by a percentage, you're taking mass that was going a certain speed, a certain percentage of your speed that was going much faster, and you're bringing it in. So it's not proportional in the sense that you haven't, your whole circumference might be reduced in half, but you haven't really doubled the speed, because it's still a mass equation in terms of what the total mass is going to be and what the average speed is over the total mass. So I don't know if you could follow what I just said, but it's sort of an interesting way of looking at it. It's just a averaging of the average speed of an average bit, and what its circumference is, or radius, would be from the center of gravity. And understanding that is, if you bring the matter in, the bits that were going faster are now going to change the average of the speed based on the density. And so there'll be the same amount of total speed, but the surface speed will increase because you've taken the speed that was on the farther surface and brought in to a narrower circumference. So at that different location, you now have more mass inside of that circumference. Therefore, you have a change in the appearance of the speed because you're looking at a different circle with a different circumference. Yeah, all right. Anyway, so they talk about that kind of stuff. So you have the rotation of like even solar systems, and then you have the rotation of galaxies. And I was just thinking about the proportional distance differences are insane. And you would think that to be commensurate to that huge difference in how far the arms are reaching out, you would have a preposterously high speed inside of a galaxy, not a lesser speed, if it was some sort of proportional thing based on total mass inside the galaxy and all that kind of stuff. It just doesn't appear that it could be on the surface. Looking at it superficially, it seems galaxies should be spinning very fast. I mean, they look to us slow, but I just mean the calculated speed should be very fast. And it's not that much faster. I mean, 10 times faster, 5 times faster. It's not that much faster. All right. And then the other point about galaxies was, so solar systems and galaxies. So I've pointed out that I think they're fundamentally different mechanisms. And I would add to that argument that they're fundamentally different in the sense that solar systems are what happen when a mass collects mass from the external universe. That will always create a solar system. And when you're expelling mass, when you're ejecting from a center that was heavier at one time and you go out, that's when you make galaxies. So galaxies are explosions of matter, in a sense, and solar systems are implosions. That's what my thinking was. So they were talking about white dwarfs and the argument that that's what our sun is going to become. And I was thinking in terms of more like, okay, it's collecting mass, but what's going to really be critical to that is all the mass that's in the solar system is going to have to be absorbed by the sun, maybe, and then it has to get smaller. It has to do this smaller density thing, and that's where it gets kind of complicated in the sense I don't think they have physics that outline how that could possibly happen, how you compress mass, you know, especially how a sun does it that's not even on fire anymore. Are bright on fire. Well, I guess white would imply some brightness, but it's not hot, as hot. Well, I have to think about that. But that's the other thing they talk about is how galaxies age, and they apparently don't have as consistent a data on that subject as they thought in terms of being able to correlate how much ultraviolet light they assume that's the hotter galaxy, the newer galaxy, blah blah blah. And I would say that that's likely in some respects, in the sense that from my argument is like a light bulb. It burns brightest when it's new and then gets a little bit less bright as it dies, and except for the very last moment when it does the spark thing. But anyway, that's another, no point in going there either. No point in mixing, though, using a metaphor that may not be appropriately used. So anyway, but it does make it understandable. It's almost like the hurricane. The energy is in the center, and it's the energy in the center moving out that creates the big giant hurricane. It's not stuff coming from the outside into the hurricane, it's stuff coming from the inside going out. And hurricanes have the same kind of look as a galaxy. And solar systems, like I said, are very different in the sense that there's nothing even or proportional or balanced in how they're expelling anything. So it's more likely that they're collecting, and they're collecting from different places, and it's smashing together into elements, being turned into particles, so to speak. It's making particles rather than destroying or breaking them, where the galaxy is doing the opposite. It's taking a particle and particularizing it, making it smaller. Bits are getting smaller. So it's almost like they talk about gas clouds collecting, and I think it's the opposite argument. It's that they collect into some sort of dark, hard mass, and then that dark, hard mass explodes slowly and creates a galaxy. And it's the gas is part of the explosion. All right. And so it just recoalesces back into what it's doing is it's condensating back into bigger particles, and that's what the suns are doing. It's the residue of the explosion turning back into particles, bits, that ultimately be a one bit again and explode again. And I think this is a function that the universe repeats, and the Big Bang may be just part of that function, in the sense that everything is doing this expansion contraction thing in a way. The push, well, I don't want to go into the push analogy because it's push, but anyway, it's no pull. Yeah, so I don't think I need to do that one. So the other thing they were talking about was when they were talking about mass, they were talking about how they don't know how to measure this thing, in the sense that there's two ways to say it. That it's how does gravity affect something? That'll give you a mass number. And then is something's inertia, something's resistance to being moved, is another way of measuring its mass. How much force is diluted by the thing you're hitting dictates its mass. You hit something really big and it doesn't go as far as something hit small. It weighs less. It moves more and more easily. But they have no explanation of the force. They didn't even say Einstein spent space. They didn't bring up anything because they don't have anything. They don't have any explanation. And the same thing happens when they talk about magnetism. They have no description of the force. They just say, well, there's field lines. There's field of force. But there's no explanation of what actually is doing the conveying or the moving. And they'll just show you the things moving, and give you the rules of the movement. But there's no mechanism for the movement, and that's just so glaring. And so again, it's while I'm arguing that I'm on solid ground in making these contentions, it's the very fact that they don't have any explanation for their fields, beyond citing a few rules of how the fields behave, but they have no mechanism. And I'm providing a mechanism, and I'm providing a mechanism that unifies every single one of the forces, which is huge in terms of a bonus. Not only are you getting a physical description, like physics should be physical, you're also given a description that fits everything, which is one of the worst liabilities of their old models, is their models aren't consistent from big universe to little universe, or from place to place, gravity, magnetism, for example. The fields are not completely. Maxwell's equations do connect gravity to magnetism, but only by the fact that they share inverse square rules and stuff, not much else. That the connection isn't in any kind of way of describing an infrastructure. And let's remember that Maxwell believed in ether, and bent space is essentially an ether. It's not bent nothing, it's bent something. Again, but it doesn't, unless you turn these fields into something. Why, you can make up the idea of saying there's 17 fields or 16 fields for every particle, for every, but does that make any sense? I mean, intuitively, or reasonably, there's no reason to think there's something coherent in all that complexity existing, and yet we can't detect field 1. We can't find any of these fields. There's 16 of them, and yet we can't find one of them. In some sort of physical way, demonstrate its existence, besides crude and simple rules, but no model of the field's function. Yeah, it's pretty glaring. Alright, so, so that's sort of what I've been thinking about. Like I said, the galaxy thing is, I think, an interesting subject because, again, it goes to the argument about whether you need a lot of mass in the center, because you could argue a hurricane has nothing in the center. The eye of the storm kind of argument. There's what seems like nothing going on there, except you have this low pressure. You have low air pressure, and a lot of it in one place. So yeah, there's something, but no wind, no evidence of that, no apparent something, just a lot of nothing in the eye of the storm. And so galaxies could be looked at, and I could say that I think there's an argument to be made that they're not evidence of something that has a lot of mass. They're evidence of something that has ejected, lost mass, a lot of mass, that it's a lack of mass. A bunch of mass surrounding a lack of mass. Sort of like the idea of going to the center of Earth. Like, people made this argument. You go, like, if we could travel to a cave or a hole in the Earth to the center, and there was an opening in the center, there'd be no gravity. We should have an equal amount of matter on each side, would be my argument. And so the effect, there's gravity, it's just the effects are balancing. Whatever's pulling you this way, there's as much pulling you the other way. So it's not like there's no gravity, there's just no evidence of an imbalance. But the trick is you really can't do any of that, because the pressure argument, you're cheating in a sense, because you're not recognizing the full force of the gravity, because the full force of the gravity is really the force the matter bits hold. The matter bits, as you go deeper and deeper into the Earth, the matter bits aren't feeling less and less gravity, in a sense. They're being affected less and less by gravity, but their pressure towards the center, their movement, their acceleration, is still strong. They're still carrying all that force pressure. So they're feeling the pressure of the stuff on the surface pushing. And so they possess a pressure that's much higher than the pressure we're feeling. So the idea would be, as you made this cave, the cave would have tremendous pressure to collapse. So as much as you could argue, oh, there's less and less gravity, there's really more and more manifestation of gravity, which is the matter wishing to move, matter needing to move, matter under pressure to move. So the potential is, energy potential is much higher in that location than what the gravity would indicate, because the gravity has been converted into material acceleration. And that acceleration has been stored essentially as like a battery stores it. It's stored this velocity that can't go anywhere, but it's still there. The acceleration is still there. So tremendous amount of pressure that the matter bits are under. So it's no longer gravity that's holding them together, quote unquote, because that's getting weaker, but it's the actual force held between the electrons and the protons is still there, and that's what's pushing everything and not allowing anything to just expand as it wishes to, allowing the electrons to just run away from the electrons and protons to run away from protons and that kind of thing, pushed away. Alright, so anyway, so it's a way of thinking about things in terms of again, the understanding the difference between a black hole and nothing, which are both consequential depending on the arrangement of the matter around them. So the idea of a black hole being a hollow thing is still not unreasonable, in my opinion, to think of in terms of what gives it its what could give a piece of dark matter, if you want to call it that, or a very heavy object more gravity, would be if it was hollow. A shell of material can create more gravity without creating too much pressure. So the argument would be is that if you compress the matter too much, like inside the sun, it'll go nuclear. You'll start fusing and breaking atoms. So to have one of these super dense objects that theoretically have this super high gravity, that would create super high pressure that the material bits couldn't survive and would do the exploding part. So it would be my argument. So in a sense, a black hole would be more theoretically possible if it was hollow. Then you could have a higher mass without creating higher pressure. Alright. Anyway, that's just not a necessary part of the theory, I guess. I mean, all these little elements, you don't know which one might produce a piece of evidence or logic that could get to issues like the important ones, which is if you can undo Einstein's prediction that photons are bent by gravity, that's a significant defect in the theory of relativity, and so that would be a win for obliging people to rethink and let go of this bent space model and go back to maybe a force model, an actual force of gravity. Turn it back into an active force in the active universe, and then realize that that active force has manifestations in other places. As I pointed out, I mean, it's all the same thing. Okay, when the photons are at a frequency, we see them as light. When they're not at a frequency, they're gravity. And when we've polarized them, not photonically by frequency, but I mean segregated them by polarization, you end up with magnetism. All the same thing, just different manifestations of the same thing, and you know, explaining the different effects. But it's all tons. We can know that. That evidence is kind of clear. The fact that they all travel the same speed, they all interact fundamentally. You know, electrons are important to all these things. Obviously, the nuclear force is electrons and protons. So, but I just, you know, so I don't want to. It's all electrons and protons. It's all A, B, and X, Y. However you want to look at it. There's two kinds of little quanta bits, and there's two kinds of active material bits. And that 2 plus 2 equals 4 filters, so to speak. I mean, it just gives you this ability to filter force. And that's all everything's a manifestation of, is how did you filter the force? Did you let, you know, you can create a filter that'll mean that everything that's going a certain way goes through, and if it's going the other way, it goes sideways, and then you change the world. So the whole perpendicular thing is another subject that came up, but I don't remember exactly how. But it certainly would have something to do with the spherical spin, and you're always leaving perpendicular, you know, no matter which way you leave. It's perpendicular to something. Alright, so that's probably enough of a video. So I'm going to try to get a little more done this week. But yeah, just there's lots of stuff on the table, so to speak. And yeah, I guess it's allergies, but man, it's almost like I can't see. You know, my eyes are just so heavy. And just can't. Yeah, not my best. But it's going to have to do. Yeah. So anyway, so probably enough of a video, and sort of an overview of the video without going into the details of what I'm arguing for. Just arguing that, you know, if you have some sort of evidence that you think is compelling evidence that it cannot, that forces cannot possibly be particles moving the speed of light, tons, then please provide it. But otherwise, they do explain they can be simply modeled to fit the evidence. And that's the argument. And so we're stuck with these two very different theories that can be molded to fit the evidence. Now, I would argue that their molding, you know, the creation of dark matter, Heisenberg, Huygens, their molding is made out of a lot of just completely made up contrivances. And that my molding doesn't really require anything contrived besides the fact that there would be rules that dictate how these simple interactions take place in the terms of the polarized function. The fact that if a black bit hits a black electron, let's say they're black and black, that it leaves perpendicularly, and if it's a red bit, it goes through. You know, the fact, just like any other, just like a beam splitter, okay, that yes, light in a certain configuration goes where it's going, in a different configuration it doesn't. Like a Brewster angle seems a very narrow rule, but it obviously exists as a rule that if light's of a certain polarization, it will be 100% reflected, and if it's the other polarization, it'll be 100% refracted. It goes through, goes in. If it's one polarization, bounces off if it's the other. One angle does that. Interesting. But it's a rule. It's obvious. Somebody doesn't have to say, oh, I contrived that. No, you didn't contrive it. It's completely consistent with the behavior. Where bent space isn't a rule. Bent space is not analogous to Brewster angle as an explanation or description. So anyway, I think I've done enough. So till the next time, hopefully a more specific video and such, and so forth and whatnot.